Now, to a method of joints, that's I've got a truss and I've got another truss, another truss. So it's jointed at the ends. So, and I want to do the analysis on this one. So method of joint means I will take only this part and then do the analysis on part A only. And I chopped it off from the joints. I did not cut it off. I'm not cutting the member. No, I am looking at the member, isolating it from the joint. So that's method of joint. So let's go through uh, this the slide, and then we'll do some exercise. Okay. So to analyze or design a truss, it is necessary to determine the force in each of its members. You have to do that. If you do not do that, then how you are going to uh, design a crane? You need to design a crane. You need to design a platform for the space station. You need to know what are the forces on each member so that it doesn't buckle or doesn't bend or break. So method of joints or method of sections. Method of joint is based on the fact that if the entire truss is in equilibrium, then each of its joints is also in equilibrium. Therefore, if the free-body diagram of each joint is drawn, the force equilibrium equation can then be used to obtain the member forces acting on each joint. I have got a truss here and a truss here. It's pin connected here. Okay, so that's pin A, B, C, and D. I can do analysis on pin A. So I'll draw pin A and I will put a force here. That's for this member. I'll put a force here. That's for this member. And I will put a force here. That is for this member. So I'm using a pin. Okay. I'll show you in the slide. Okay. So method of joints, relatively easy. Method of joint. The correct sense of direction of an unknown member force can, in many cases, be determined by inspection. Yes, remember when you assuming the direction of force, you can use a bit of common sense to figure it out. What is the direction? But don't worry, if you get it wrong, the answer will tell you that. Assume the unknown member force acting on the joint free body diagram to be in tension. That is the force pull on the pin. Or you can do it in compression. So I won't stick to this point, but it makes life easy. But as I said, whatever you assume, stick to it. The answer will tell you if your assumption is right or wrong. Then draw the free body diagram of the joint having at least, this is very important. Draw the free body diagram because you got a truss. Okay, look, you got truss, so many truss. Okay, so force may be given here, force may be given here, force may be given here, a force may be given here. So it says here, draw the free body diagram of a joint having at least one known force and at most maximum of two unknown forces. If you have to find, for example, I've got this structure here, and I want to know the force this point here, then I cannot draw the free body diagram of point A, because if I draw the free body diagram of point A, I've got the force here, force here, force here, and force here. Sum of all the forces, all are unknown. I should start from a point where I've got one known, and two unknowns maximum. That is the right place to start your analysis. That's what it says here. Okay, let me read it again for you. It says here, draw the free body diagram of a joint having at least one known and a maximum of two unknown forces. If this joint is at one of the supports, then it may be necessary first to calculate the external reaction at the support. Interesting. Again, let me draw the truss here. That's a truss. I draw another truss here, and another truss here, and another truss here. I've got force being applied here. I've got, this is a support, and this is also a support, and uh, and uh, and I've got a force here. Now I want to do the analysis of this. So I've got two supports. I will be able to get the reaction of the supports if I look at the equilibrium of the whole system. For the whole system, I will have a structure with R1 and R2 with force being applied here and force being applied here. This is the equilibrium of the whole structure. If I look at the equilibrium of the whole structure, I will be able to get my R1 and R2 out. Am I right?
Yes, sir.
So once I get my R1 and R2 out, I can apply it here and then start doing analysis inside the members. Okay, don't worry. We'll do an example and it will be very clear to everyone. Just stay with me. And this thing will be very much clear when we do the exercise. Use one of the two methods described above for establishing the sense of unknown force. Yes. You have to orient your coordinates of x, y, get your x, y coordinates in the right way so that uh, applying equation of equilibrium is relatively easy. I've already covered this before. Use the calculated results, continue to analyze each of the member or joints. Remember that a member in compression pushes on the joint and a member in tension pulls on the joint. Also be sure to choose a joint having at most two unknowns and one known force. Yes, I've been forcing this again and again. You start your analysis from a joint which has got one known and maximum of two unknown forces. Okay, so